Today I'm going to be doing a blockchain programming example in C++. So before we get started, I just wanted to give some credit to Xavier. Xavier has a YouTube channel where he talks about pretty much anything you wanted to know about blockchain, including programming examples. And one of those videos is Create a Blockchain in JavaScript. It's a great video, and it's in his programming example series. He has 2 videos in that series for this particular topic. And I recommend you just going to see both of those videos if this topic is interesting. Alright, and then a disclaimer real quick. I have no idea what I'm doing. C++ is not my language. JavaScript is my first language. But I wanted to challenge myself in C++, so here we go. Alright, to get us started here, I've created a main C++ file. I've included a couple of headers, ctime and vector. Ctime gives us some functions we can manipulate date-time objects with. And vector is a data structure similar to an array, but you do not have to allocate memory at design time. You can actually grow and increase the size of the vector at runtime, which is good for me because I don't know what I'm doing with C++. There are ways to do that with an array, but this is demo purposes, and we don't want to go into the ins and outs of dynamically allocating memory, which I'm not very good at anyway. Alright, so I'm going to make some comments here about what we need. We need some transaction data. Block class, and we need blockchain, of course. So transaction data is going to go within the block class, so every block will have multiple transactions, but in this case we're just going to have one transaction per block. And then blockchain will obviously contain every block. For demo purposes, we're going to do a struct. And that's going to hold a double amount and a string sender key, string receiver key, and also a timestamp. Alright, so we also need a block class. And in our block class, we have some private members, some public members. Private members are going to be an index for this block, and a block hash, and previous hash. And then generate hash function. So size t is an unsigned integer type, and that's actually what gets returned when you use the standard library's hash function. So under public, we're going to have a constructor, and this constructor is going to take in an index and a transaction data object, and also the previous hash. We're also going to have a getter for hash, and then you get previous hash, and this is so that we can compare it later if somebody tries to mess with this, with any of the transaction data. And this is going to be the data member, transaction data member. I'll just add a comment here. because we're going to do something a little different to this later on. And then we need a way to validate the hash. So we're going to have a function that returns a boolean called isHashValid. And that sets up what we need for this class. Let's go ahead and define our blockchain class. Alright, here we're going to need class blockchain, private, and public members. We need a block, create Genesis block. I know in C++, most editors have you do that, and that's kind of the standard de facto way of writing a class. I don't like that. Maybe it's because I come from JavaScript land where everything's indented, or if you come from Python where everything has to be indented, and that's actually how the interpreter interprets Python, is you have to have those indentations. C++ can be a little weird. Alright, so we've got a private, public. Public will be, let's see here, we need a chain, obviously, which is going to be a vector of blocks. Stop doing that, Visual Studio Code. So we'll give this a comment, public chain. This is going to be the constructor. And we've got some public functions. And one of those is going to be add block. And it's going to take in transaction data. And then another is going to be, oh, breaking news, North Korea, something about Kim Jong-il. I hope we're not being bombed right now. I'll look at that later. So I wanted to put this comment here because I'm going to add a block, or a function that returns a block, but this is going to be a pointer, so that later on we can fake manipulate the data inside that block, so that we can verify that validating the block works. Alright, and that's going to be it for our blockchain class. Alright, so now we need to create the constructor. Constructor with some params. That's going to be off the block class. It's going to take in an index, transaction data, and then this unsigned integer that represents the previous hash. Index is going to be equal to this index that we passed in. Data is going to equal transaction data. And this hash is going to be equal to this prev hash. And block hash is going to be equal to what this generate hash function returns. Okay, and now we need to create the private functions. The first one is going to be actually the only private function that we need. It's going to be this generate hash function. What we're going to do is use this hash type. The first hash is going to be a string. It's going to take in a string. Second hash is going to take in an unsigned integer. And the third hash is going to be the final hash, which is going to be an unsigned integer as well. Alright, so what we're going to do here is we are going to take the data amount, turn that into a string. We're going to concatenate that with a receiver key and a sender key, and then also we're going to toString the timestamp. And then we're going to return a final hash that takes in the concatenation of those first two things. Okay. Visual Studio Code doesn't like that, but I think it will work. And then we need some public functions. And we need a get hash function that just returns the block hash member. I'm just going to copy this. We also need a get previous hash. It's going to return previous hash. Alright, we need one more public function, which is going to be Boolean. It's going to return a Boolean, and it's going to be is hash valid. And what we're going to do here is return if generate hash is equal to block hash. So what that's going to tell us is if someone manipulated any data in the transaction data and you try to generate the hash again, then it's not going to be equal to the block hash member because someone manipulated something in that data, and this hash is not going to be the same anymore. Alright, so now we need to implement the blockchain class members. So we need a constructor. And constructor is going to just be a default constructor. It's not going to take any arguments. And it is going to create a Genesis block. Using a new function that we'll create. And then it is going to push the Genesis block onto the blockchain. Alright, so now we need to create the create Genesis block function on the blockchain. That's going to return a block. remember the block constructor takes in an index, some transaction data, and the previous hash. So that's what we need to create here for this initial block. And the Genesis block it's the first block on the chain, so it doesn't need anything special as far as data. So we are going to add a current timestamp, transaction data, and the transaction data, because it's the first data, it doesn't really matter what's in here. And the timestamp is going to be using the time function. We're going to pass in a pointer to that current time. And then we need a hash of type int, or that takes in an int. And we're going to create a Genesis block here. We're going to pass in 0 for the index, this data struct that we just created, and then hash with just 0 in it, and that'll give us something unique to start out with. And then we return Genesis block here. Alright, if you remember earlier, I said we were going to do something a little bit different for this getLatest block function. This is bad. Just do this, only for demo. And what we're going to do is return a pointer. If you don't know what a pointer is, if you are a JavaScript person, a pointer is a way to reference something in memory. It actually gives us a memory address. It's a pointer to a memory address. And what we can do with that is we can actually manipulate the data inside that memory address. So ordinarily, if we were to do this without a pointer, it would return the latest block off the chain, but that would be immutable. And since we're returning a memory address, then we can manipulate the data inside that address. So we are returning a pointer. And now we need to implement this add block function, which takes in some transaction data, and we need an index for this. So we are going to get the size of the chain, and we're just going to take 1 off of that, and that'll give us our index. And then we need to create a new block from that index plus the data, and now we're using that pointer to get the hash off of it. Alright, so now we need to implement our isChainValid function, which is going to return a boolean. And we need an iterator that iterates over a vector of type block. And we need a chain length variable. So we're going to get the size of the chain. And for some reason in C++, when you get the size of a vector, it actually returns something other than an int. any of you C++ people out there know anything about that, please leave a comment. Let me know why that is. Alright, so we're going to, whoops, yeah. So this iterator is going to be set to the first member of the chain to begin with. And then if it doesn't equal the end of the chain, then increment that iterator and keep going through. So inside of this for statement, we need the current block, and this comes straight from SubG's demo, except he's just using I think it's a for loop that loops over an array, and here we're using an iterator. So what we're going to do is say if that current block doesn't have a valid hash, then just get out of here, return false. Right? So the chain's broken, the chain's valid if that current block has an invalid hash. And then if the chain length is greater than 1, then we can check to see if the previous hash equals the previous hash that's in this current block. So we're going to say block, previous block equals iterator minus 1. Right, and then if the current block has a previous hash that is not equal to the previous block hash, return false. So this basically means if we have to return false here, this means somebody messed with our stuff. Somebody tried to jack with a block in the chain, or transaction data that's inside of a block. Alright, so I just realized why Visual Studio Code is complaining about this. And it's because it's chain valid up in the header is declared as void, which means it doesn't return anything. But that's not what we want with my Boolean. C++ people, do you call it Boolean, or do you just call it bool? We always call it Boolean in JavaScript. Okay, so now we're ready to start using this stuff. So we can create a main function and start a blockchain. We are going to call this blockchain awesome coin. That'd be cool. So we started a blockchain, or a new token called awesome coin. I bet somebody has already done that. I saw one. Alright, we need some data for the first block. First, we'll say this is first added block. I was looking on a website today that has lists of ICOs, and one of the ICOs was called, well, it was called this. So, you guys look that up. And it's actually doing quite well. I'm not going to invest any money in that coin, but it's out there. Alright, so we've got a blockchain. We need some transaction data.
Mấy cái này. Ok, bây giờ đặt sao đây? Số 5 là cái gì đây? Số 5 là play. Đặt đi, đặt đại đi. Hình số này.
The transaction data needs a timestamp and it needs
Ok, và bên kia thì chúng ta sẽ đặt những cái thứ còn lại. Màu vàng nè,
an amount.
màu hồng, rồi xanh.
So we're sending 1.5 awesome coins. Awesome coin. Revolution in blockchain technology. C++ developed by John from Crypto Enthusiasts. You guys don't get it. I'm gonna put this up there. We're gonna start an open source revolution. Alright, we need a receiver key. And you can tell this is just not my thing. The sender key.
Rồi bây giờ thì mình sẽ làm lại nha. Ok, cái nút kia của mình đâu rồi?
Call it data.
Chúng ta sẽ lại nha. Let's go. Hồi nãy là màu xanh lá này là số 5, còn màu cyan này là số 9.
We got some stuff. We can stuff inside an awesome coin block. Get some transaction data. And now we are going to get some coin. This block.
Thấy chưa các bạn, thấy chưa? Nó theo cái nguyên lý là ở trên cái chế độ sáng tạo á, nhưng mà các bạn đâu có nhớ được đúng không?
So now we're going to check and see if
thôi bỏ qua đi. Và tiếp theo sẽ là đến với căn phòng thứ 3 thì nó sẽ cho mình cái này. Ok, để coi là cái gì đã. Ok, và police là cái gì đây? Có trên đây không? Ý có nè.
That's the other way.
Rồi.
We don't want to do that. We don't want to take in anything.
Khoan. Chết rồi.
I'm going to print some stuff out. I'm going to do an indel. Inline. I know that because I'm a C++ expert. We're going to
police là cái này nó sẽ có ô thì cái chữ nào mà nó có chữ police này thì chúng ta sẽ đặt.
We're going to see if this chain's valid.
White red là đặt ở đây hoặc là này đúng không? Là sao ta? Ở trên này.
Alright, so let's save that and hold on to your butts. We're going to compile this with the G++ compiler, which is the best way to compile a C++ program. I'm on a Mac, so you could do this or you could use Xcode. Xcode's actually pretty good. Alright, so we're going to say G++ main.cpp. And then our output is going to be awesome coin. Let's see if this works. Hey, look at that. And yes, this code is in my Google Drive. Alright, so let's run this bad boy. Alright, cool. So that 1 right there means our chain is valid. By the way, this is what happens when you do when you return a boolean in C++. It's either 1 or 0, 1 being true, 0 being false. For all of you JavaScript people out there.
Yes, all right.
And then let's see. You know what? Let's create some more data. I'm just gonna copy all this right here.
Ok, chúng ta đến với căn phòng thứ mấy rồi không nhớ. Ok, let's go. Ok, nó còn một quyển sách. Make a chat and then reset. Mình sẽ làm một cái chat và mình đặt là set. Ok, và đây rồi.
Có chỗ rồi. 0.000133322 amount.
Và mình sẽ đổi cái chat này tên là
Martha is gonna set that to Fred.
Lấy gỗ nè. Rồi, bây giờ thì đổi ra.
We're going to add that block to the chain.
Ok, bạn chế tạo rồi, bây giờ đặt vào đây.
Say,
rồi bây giờ thì mình khoan từ từ. Cái gì vậy? Cái gì vậy? What? No, sao mày cho như vậy? Ổ mắt hết cục luôn rồi. Trời ơi, thôi nổ luôn đi. Mày nổ giùm tao đi. Ức chế thiệt rồi, thôi lại nha. Cố gắng làm thật là nhanh lên các bạn ơi. Bây giờ thì đổi gỗ khoan từ từ, lụm vô. What?
we're going to compile it again.
Rồi, ok, làm một cái bài chế tạo. Rồi, nó cho
Run it.
chế tạo là mình không kiểm chắc luôn.
Hey, it's still valid.
Rồi, sao có bảy cục vậy?
Alright, so now
Men, sao cái cục này nó cứ rớt ra ngoài? Mình không hiểu tại sao nó lại rớt ra ngoài.
we're going to get sneaky.
Phải nè, lần này là phải thành công nha các bạn. Lần này là phải thành công á. Ok, đổi ra.
So it's getting sneaky.
Tắt hết đó. Rồi, ok.
We're going to call this block.
Rồi, bây giờ thì mình sẽ đổi đó là save. Rồi, ok và yes, thấy chưa? Cứ bình tĩnh là làm được, đơn giản vậy thôi. Rồi, ơi nó cho mình chết này luôn các bạn, nó không có lấy lại luôn. Rồi và đến với tiếp theo là
return a pointer, which you wouldn't ordinarily do, but we're doing it for demonstration purposes. Because this is potentially how somebody could hack a blockchain. They could somehow get a memory address, get in there, mess around, manipulate some transaction data, and that could have really bad repercussions. So we're gonna say, take this pointer, and we're gonna get the data out of that pointer. Data struct member. Whoops. We're gonna hack the amount, so we're gonna say 10,000 awesome coins are going to intelligence. Nice. We're going to say 10,000 awesome coins are going to me, John, from Crypto Enthusiasts. Throw that in there too.
Rồi mình nhớ rồi. Bây giờ thì là red là ở đây.
If I can spell enthusiasts.
Rồi tiếp theo là số 1 là 1 cam, mình nhớ kỹ mà. Số 5 ở
I wonder how many people have just stopped watching this now.
Rồi màu tím là cái này.
Now that it's really getting interesting. Alright, so now is the chain still valid?
Sai chỗ nào hay sao? Số 3. Số 3 khoan, mình sai một cái chỗ nào đó. Các bạn dặm thì để làm cái gì ta? Hay là mình phải dặm lên đây mới được à? Ok, lại thử coi coi. Hai cái bạn dặm là. Ok, để thử lại nha, nhớ đi. Mình nhớ mấy cái này rồi, chứ bây giờ là cam nè, rồi vàng nè, đó, rồi màu này. Thì mấy cái này ở trên đây nó đã ghi sẵn hết rồi. Chả qua là các bạn nhớ là cái vòng hồi nãy thôi. Số 2 là cái nào ta? Số 2 là cái chết rồi, mình quên mất tiêu rồi. Mình quên rồi, số 2 là cái
No, it's not valid. Why is it not valid? Well, because somebody messed with this data.
Nó vừa nổ luôn mà mình vừa được.
John from Crypto Enthusiasts wanted to get 10,000 awesome coins in his wallet. But it didn't work. Why didn't it work? Well, because we manipulated this, and when the isChainValid function ran, it checked to see if this hash was valid. This is going to go to the function definition. Hey, look at that. If you hold down the function key in F12 on a Mac, Visual Studio Code, it'll jump right to that function.
Wow, cái này khó vậy.
Definition. Yeah. So here it ran this generate hash function. The generate hash function took the data from the transaction data and created a hash out of it, and then compared it to the block hash member that's already inside that block. And since those things don't equal, that means somebody did something sneaky. So that, my friends, is how a blockchain works at the very, very, very basic, non-expert C++ programming level. And that's it. Thanks for watching. Make sure to like and subscribe, and I'll see you in the next video. Also, go to Sevji's channel, because he's awesome, and his videos are very informative, and I basically just stole his example and turned it into some really nasty C++. Thanks. Hey there, welcome to another crypto enthusiast blockchain community video. Today I'm going to be doing a blockchain programming example in C++. So before we get started, I just wanted to give some credit to